Welcome to Spring LIB.
Hello students, here given that the speed of sound is human tissue is 1540 meter per second and an echocardiogram uses a frequency of 4.4 megahertz. And for the first part of the question, if the blood is moving away from the probe at 1.3 meter per second, what will be the measured shift in the frequency of the reflected ultrasound? So here the velocity of blood is equal to 1.3 meter per second. In this case, we have to calculate the Doppler shift. So the Doppler shift, which is denoted by delta F, and this is equal to minus 2 Fs into, that is the source, into the speed of blood divided by the speed of the sound. And in this case it is equal to minus, here why we are using minus is the blood is moving away from the probe, so in opposite direction, so we are using minus, and this is equal to 2 into 4.4 megahertz, so 4.4 into 10 power 6 into velocity of blood is 1.3 divided by the velocity of sound is 1540, and this gives the Doppler shift of minus 7428.5 hertz, or we can write delta F is equal to minus 7.43 kilohertz. This is our first answer. And for the second part, so we have to calculate how the answer will change if the blood is moving towards the probe at the same speed. So if it is moving towards the probe, if blood is moving towards the probe, then the value of frequency, that is the value of shift, will be the same, but the sign is different. The sign is opposite. So delta F is equal to plus 7.43 kilohertz since it is moving towards the probe. And for the third question, we have to calculate the slowest speed of blood the device will detect if the resolution of the device is 0.01 kilohertz. That is the minimum shift. Minimum shift delta F is equal to 0.01 kilohertz, means then we have to calculate the slowest speed that the device will detect. So here we can use the same formula as we have used above, that is delta F is equal to 2F into velocity of blood divided by velocity of sound. And in this case, delta F is equal to 0.01 into 10 power 3 is equal to 2 into 4.4 megahertz into velocity of blood, and this divided by the velocity of sound is 1540 meter per second. And solving this, we can get the minimum velocity that the instrument can detect. So velocity of blood is equal to 0.01 into 10 power 3 multiplied by 1540 divided by 2 into 4.4 into 10 power 6. And this will be equal to 1.75 into 10 power minus 3 meter per second. This is the minimum speed that the probe will detect. Hope you find this video is useful. Thank you.